Nowadays, taking care of the environment is a crucial goal for humankind. But even though most people think about preserving whole forests, maintaining green spaces inside cities is also key, since they offer vast health benefits, especially for economically deprived communities. To achieve good urban green coverage, it is needed urban planning with solid data, what is not a reality in most parts of Brazil, where the lack of data and funding are important obstacles to urban planning. These are the problems which the Columba mission focuses on. The selected target is Rio Branco, the capital of the state of Acre, because although it is located in the middle of the Amazon rainforest, Rio Branco is the least arborized capital in Brazil, making it an ideal spot of application of our satellite. With our mission, effective and cheap data about urban coverage can be gathered and help the capital to cooperate with its inhabitants' health. Our satellite is a two-unit structure entirely based on commercial off-the-shelf components, being projected, built and tested by PoliSat, a group born in 2021 composed by 30 students from the University of São Paulo. At the end of the day, the goal is to have all systems working nominally, supporting the action of our payload.
The payload was designed in order to gather many indicators of urban green coverage. To accomplish that, a GPS module worked with a Raspberry Pi high-quality camera, enabling our OpenCV-based code inside a Raspberry Pi Zero W to filter the captured images. As a result, indicators of shape, size, and aggregation are gathered and sent back to Earth.
Of course, this data has to be sent back to Earth, function made by the Telecommunications system.
The TT&C subsystem gathers all data needed for telemetry and organizes it into different types of packets, such as a housekeeping packet and a payload packet, which contains the payload data. We have also defined uplink communications in order to send commands to the satellite, like redirection, gathering sensory data, and all these packets go through a serialization process, and the signals then amplified before being sent via the antenna on ultra-high frequency.
Columba also counts with a crew for the energy and power supply system development.
The electronic power system is dedicated to the production, storage, and management of power in the satellite. Power is generated by 4 solar panels positioned on different sides of the satellite, increasing the power output and the possibility of at least one panel being illuminated at a time. MPPT circuits are employed in order to maximize efficiency. A lithium-ion battery charger ensures the quality of the power supply to the cells while allowing for multiple charging configurations. Aiming to accommodate components with different power demands, DC-DC converters were used.
To ensure the safety of the batteries and a good functioning of all parts, a thermal control system is needed.
The control system is responsible for keeping all component temperatures in the operational range through active or passive control. We projected the passive control using finite element simulations in ANSYS, which provide analysis of the capital film used to insulate the satellite. On the other hand, the active control consists of a chromometer wire. This control is necessary for the batteries and the Raspberry Pi camera, because each one has short temperature ranges.
To control our device, an onboard data handling system was developed.
The main objectives of the onboard data handling subsystem are to control the satellites, store data, and to interconnect the subsystems allowing for communication between them. Moreover, it is also responsible for the coding and executing the telecommands obtained by the TNC. The selected microcontroller is the STM32F0 nuclear board, along with an SD card for storage. The communication with the other subsystems and sensors were established with SPI and I2C buses, and the program flow was done as a state machine.
As an upgrade, Columba counts with attitude determination and control system.
The attitude determination control system controls the orientation of the satellite in one direction. For tracking and stabilization objectives, a reaction wheel is integrated into the control loop. The actuation depends on the data gathered by the microcontroller from the sensors, which are the encoder, the gyro sensor, and the algorithm produced by the team to detect a source of luminosity. The system is also responsible for simulating the satellite's orbit, a low Earth and sun-synchronous orbit of 567 kilometers altitude and 98 degrees inclination.
Finally, all systems are held together and protected by the structure.
Our approach was to create a structure from aluminium 775 with 4 rails connected by 2 bases, which are formed by 4 pieces. All connections between pieces are made with bolts. Since our goal is to produce the CubeSat, the manufacturing drawings from the structure were developed and finished, besides the simulations on the machining of the pieces, made with VKM software. To validate the mechanical properties, simulations were also carried out. This way, we want to assure that Columba would be ready to launch in a hypothetical situation.
Regarding the budget, the team had $2,000 for 1 year of project, granted by the institution Amigos da Mundo. This funding made it possible to build a prototype that allowed the members to develop and learn. We estimate that a real launching project would cost 150 times more than the prototype, and the project cycle should last about 2 years.
The technical project will finish by the beginning of July, while manufacturing and assembly will happen during August. Until then, PoliSat keeps pushing and setting our sights even higher.